Solid ground is one of our most fundamental illusions. Entire continents have vanished beneath the ocean, taking forgotten worlds with them. By the end of this journey, you will see the map of our planet not as a fixed image, but as a single frame in a breathtaking film of destruction and rebirth. We will uncover how a real eighth continent was discovered underwater and investigate whether ancient flood myths are distant memories of these catastrophes. What does it mean for our future when the land itself can be so temporary? Our planet's first solid skin was nothing like the world we know today. It was a thin, fractured shell on a ball of molten rock, a dynamic canvas where the very concept of a continent was being invented for the first time. The first landmasses to emerge were the cratons, the ancient hearts of our modern continents. These were not the sprawling plates we see now, but smaller, denser blocks of relatively light rock that literally floated on the planet's seething mantle. Their formation was a spectacularly violent process, a continuous bombardment of asteroid impacts and colossal volcanic eruptions that spewed forth the very material that would become our foundation. In this primordial chaos, stability was a fleeting dream. A landmass could rise from the magma ocean, only to be torn apart by the mantle's fierce convection currents or dragged back into the abyss before it could ever cool. The evidence for this relentless cycle is written in the world's oldest stones, in the ancient gneisses of Greenland and the Jack Hills of Australia. These rocks, some over 4 billion years old, bear the scars of multiple formations and destructions, a geological palimpsest where each chapter is written over the last. This was the brutal nursery where continents were born, a place of constant flux that established a fundamental truth of our planet. The ground beneath our feet has always been temporary, and the stage was now set for even grander disappearances. This grand tectonic rhythm has a name: the Supercontinent Cycle. It is the slow, powerful heartbeat of our planet, a pulse that beats once every 300 to 500 million years. You might know its most recent creation, the great land of Pangaea, but that was only the latest. Before it came Rodinia, and before that, Nuna, each a sprawling empire of rock that once united nearly every scrap of dry land on Earth. The cycle always follows the same epic pattern. Continents, carried by the slow conveyor belts of the mantle, slowly drift together over ages. Their collisions raise mountain ranges that scrape the sky, welding the fragments into a single, colossal supercontinent. But this is where the drama truly begins. This massive landmass acts like a thick, insulating blanket, trapping the immense heat rising from the planet's core. That heat has to go somewhere. It builds and builds beneath the supercontinent until the pressure is too great. The land itself begins to crack, to rift apart, as plumes of superheated rock surge upward. Great fissures open, which fill with water to become new oceans, while the fragments of the old supercontinent are pushed apart, destined to wander the globe alone once more. This endless dance of assembly and breakup is the ultimate architect of our world's map. It dictates when continental shelves are stretched so thin they sink beneath the waves, and when sea levels fall to reveal new land. It is the overarching reason why continents vanish, and to see its most stunning legacy, we must look to a continent that was lost for millions of years. Plato's Atlantis stands as the ultimate ghost in the machine of history, a story so compelling it has refused to die for over 2,000 years. The tale comes from two of his dialogues, Timaeus and Critias, where he describes a formidable naval power that ruled over a vast island empire from a magnificent capital city built in concentric rings of land and water. This civilization, he claimed, became arrogant and attempted to conquer the ancient world, only to be defeated by the ancestors of the Athenians. Its final punishment was cataclysmic. The entire island, along with its armies and glory, was swallowed by the sea in one terrible day and night. Plato was very specific about the location, placing it beyond the Pillars of Hercules, what we now call the Strait of Gibraltar. This single detail has launched 1,000 ships, both literal and metaphorical, sending explorers searching for its remains deep in the Atlantic Ocean. Yet no trace of a sunken continent has ever been found there. This glaring absence has led many scholars to conclude that Atlantis was never meant to be a real place, but rather a philosophical allegory. It was a cautionary tale about the dangers of hubris and the collapse of an ideal society, a powerful metaphor crafted by one of history's greatest thinkers. But what if the power of the story comes from a different kind of truth? The human mind is a remarkable archive, and cataclysmic events, like the sudden submergence of coastal land, can be seared into collective memory. Over generations, the specific details of a real disaster can blur, transforming into the legend of a golden city lost beneath the waves. The relentless search for a literal Atlantis, while fruitless in its primary goal, has ironically driven real scientific discovery. It has pushed explorers to survey the seafloor with greater care and has fueled the investigation of actual submerged ruins in other parts of the world. The myth's enduring grip points not to a map coordinate, but to a profound geological reality we now know to be true. Continents can and do sink, and we have found one. This sunken world is not a legend but a fact confirmed by science in 2017. Zealandia, Earth's 8th continent, lies almost entirely beneath the waves of the Pacific. It is a colossal landmass of nearly 5 million square kilometers, a vast territory where the only visible landmarks are the islands of New Zealand and a few smaller outcrops. These are not islands in the traditional sense, but merely the highest mountain peaks of a drowned world, representing a mere 6% of its total area. Zealandia is not a collection of ocean floor volcanoes or a thickened patch of seafloor. It is built from a different kind of rock entirely, a thick, buoyant continental crust that just happens to be mostly underwater. This is what makes its existence so revolutionary. It shatters the simple definition that a continent is land you can walk on. Instead, it is defined by its geology, a massive, coherent piece of the planet's continental shell. So how did an entire continent end up at the bottom of the sea? The story begins around 80 million years ago, when Zealandia was still firmly attached to the supercontinent Gondwana, the southern counterpart to Pangaea. As the tectonic plates began to move, Zealandia started to pull away, but this was not a clean break. The crust was stretched almost like warm taffy over an immense area. This stretching caused it to thin and weaken, losing the natural buoyancy that keeps standard continents high and dry. It became a low-lying, fragmented world, a vast continental plateau. The final act of its drowning was a 1-2 punch from geological and climatic forces. The thin, weakened crust continued to slowly subside, and then, after the last ice age, rising sea levels delivered the coup de grace, flooding the remaining lowlands and completing its transformation into a submerged realm. The evidence for this lost continent is not hidden. It has been gathered from rock samples drilled from the seabed that are unmistakably continental, from satellite maps that chart the subtle gravity anomalies of its thick crust, and from detailed sonar surveys that have meticulously mapped its drowned mountains and valleys. Zealandia stands as undeniable proof that continents are not permanent. They can be stretched, they can sink, and they can vanish from sight for millions of years. And this modern discovery gives us a new set of eyes, a geological template for finding other lost worlds, perhaps even one whose story is written not in scientific papers, but in the ancient myths of human civilization. The story of Zealandia unfolds over deep time, a slow geological epic, but our planet holds evidence of a much more recent disappearance, one that unfolded within the span of human memory. This is the lost world of Sunderland. Just 20,000 years ago, at the peak of the last ice age, our planet looked profoundly different. So much of the world's water was frozen into colossal ice sheets that the global sea level was over 100 meters lower than it is today. This exposed a vast, Texas-sized continental shelf that connected modern-day mainland Southeast Asia to the great islands of Borneo, Sumatra, and Java. This was not merely a narrow land bridge, but a genuine subcontinent of forests, rivers, and savannas, a world we now call Sunderland. This sprawling landscape was almost certainly inhabited by early human populations, hunter-gatherers who lived and hunted across its expanse. Then the world began to warm, the great glaciers melted, and the oceans began their relentless rise. For thousands of years, from around 14,000 to 7,000 years ago, the sea crept inland in a slow-motion deluge. Coastlines retreated, not in a single cataclysm, but in a steady, unstoppable advance. Generation after generation would have witnessed this change, seeing familiar hunting grounds and ancestral lands gradually consumed by the water. The psychological impact of such a loss is almost impossible to overstate. Can you imagine the stories that would be told, passed down from parent to child for centuries, about the once great lands that now lie beneath the waves? It is here, in this prolonged human experience, that many researchers believe we find the seed of a universal story, the great flood myths that appear in countless cultures across the globe. The evidence for Sunderland is not merely speculative. Sonar maps reveal the ghost of its ancient landscape, showing the distinct, winding channels of drowned river systems sprawling across the seabed. Core samples from the ocean floor contain pollen and sediments from long-vanished forests. The distribution of animals and plants adds another layer of proof, with closely related species found on islands that were once connected, separated only by the rising waters. The submergence of Sunderland is not an abstract geological event. It is a story of human displacement, of lost homelands, and of myths born from real, witnessed trauma. It proves that the sinking of continents is not just a feature of the distant past, but a force that has actively and directly shaped the course of human history and the very stories we tell about ourselves. This process of continental drowning is a battle of density and buoyancy, a slow war waged deep beneath our feet. For a continent to vanish beneath the ocean, its very essence must be transformed. The secret lies in the rock itself. Continental crust is the lightweight champion of the planet's layers, typically 30 to 50 kilometers thick and composed of relatively light rocks like granite. This low density gives it immense buoyancy, allowing it to float high on the much denser, semi-fluid mantle below, much like a thick block of wood floats on water. To make a continent sink, you have to change that fundamental equation. You have to compromise its natural ability to stay afloat. One of the most powerful mechanisms is tectonic stretching. Imagine the crust as a piece of warm taffy. When colossal forces within the Earth pull it apart, it doesn't just break cleanly, it stretches and thins over an immense area. This thinning crust loses its structural integrity and, crucially, its buoyancy. It becomes a weakened, low-lying plateau that can no longer resist the relentless pull of gravity, slowly subsiding beneath the waves. This is precisely what happened to Zealandia. Another relentless force is thermal subsidence. picture a continent sitting over a massive, superheated plume of mantle rock. This heat causes the rock to expand, creating a broad, buoyant dome that lifts the continent. But when that heat source shifts or fades, the mantle material cools and contracts. As it shrinks, it drags the entire section of crust down with it, like a deflating balloon sinking in water. Add to this the immense weight of geological features. Catastrophic volcanic eruptions can pile layer upon layer of heavy basalt rock onto the crust, while the accumulated weight of sediments washed from mountains over millions of years can slowly depress a continental margin like a person sinking into a soft mattress. Finally, we have the global influence of climate. During ice ages, vast quantities of water are locked away in glaciers, causing sea levels to plummet and exposing continental shelves. When the climate warms and the ice melts, that water returns to the ocean basins. This rising sea level can drown vast, low-lying coastal plains and continental shelves, making them appear sunk even if the crust itself hasn't moved an inch. It is this last process that sealed the fate of Sunderland. By understanding these mechanical processes, we can read the scars on the ocean floor not as random features, but as the telltale signs of a continent's demise. This geological toolkit gives us the means to investigate one of history's most tantalizing enigmas, a lost land whose story is written not in rock, but in the collective memory of an entire civilization. The legend of Cumry offers a different kind of truth, one written in poetry and cultural memory rather than in sonar maps and rock cores. Ancient Tamil literature speaks of a vast and sophisticated land, a cradle of civilization that stretched far south of modern India, connecting it to Madagascar and even Australia. This was not a mere island, but a continent called Cumry, home to a great Tamil culture that was lost in its entirety to a catastrophic flood. The stories describe a land of immense beauty and learning, swallowed by the ocean as punishment for human transgression. From a purely geological standpoint, the evidence for a sunken continent of that scale in the Indian Ocean does not exist. The seafloor there is primarily composed of dense basaltic ocean crust, not the buoyant granite of a lost continent. Yet, to dismiss the story entirely is to miss its profound resonance. At the height of the last ice age, the map of this region was dramatically different. Sea levels were so low that a vast shelf of land, now submerged, connected India to Sri Lanka, and smaller land bridges extended further into the archipelago. This was a real, habitable world that was slowly drowned by the rising post-glacial seas. Could the legend of a great lost land be the cultural echo of this actual event, a memory of coastal plains and river valleys that vanished over generations? Furthermore, the Tamil people have witnessed their history literally sink. The ancient port city of Puhar, described in the same epic poems that mention Cumry, is believed by many archaeologists to lie submerged off the coast of Tamil Nadu, a victim of local subsidence or a powerful ocean surge. The loss of such a prominent city, repeated along a coastline, could easily have been magnified over centuries into the legend of an entire continent lost. The power of Cumry is not in its literal geography, but in what it represents. It is a story that encodes a real and terrifying experience, the relentless advance of the sea and the loss of ancestral homes. These legends challenge us to listen more carefully, to understand that our oldest stories are often not mere fictions, but long-remembered histories dressed in the language of myth. They are a testament to humanity's deep, ancestral fear of the sea's power, a fear that finds a startling new dimension when we look not to the past but to the future. The echoes of Cumry resonate far beyond the shores of India, finding a chorus in the most ancient stories of humanity. From the Epic of Gilgamesh to the story of Noah's Ark, cultures on every inhabited continent tell a remarkably similar tale. A great world-ending deluge is sent by the gods, a few virtuous survivors are saved, and civilization is forced to begin anew. This is not a coincidence. The indigenous peoples of Australia speak of a time when the sea rose to claim the land. Native American tribes have legends of a great flood covering the mountains. The ancient Mesopotamians inscribed their version on clay tablets. This global tapestry of flood narratives points to a shared, profound experience. A single flood covering the entire planet is geologically impossible, but a universal pattern of localized catastrophes is not. The slow, inexorable sea level rise that drowned Sunderland over millennia was not always a gentle creep. It was punctuated by moments of sheer terror. Imagine a colossal glacial lake like North America's Lake Agassiz, a vast inland sea held back by a wall of ice. When that ice dam finally fractured, it would have unleashed a cataclysm. Trillions of gallons of fresh water would have surged into the ocean in a geological instant, causing rapid, devastating sea level surges that would have inundated coastal plains without warning. Or picture the catastrophic collapse of an entire volcanic island slope, sending a mountain of rock into the sea and generating a tsunami that would have scoured coastlines thousands of miles away. For the communities living along those vulnerable shores, these events would have been absolutely apocalyptic. Their entire world, everything they knew, would have been erased by the water in a single, horrifying day. The trauma of such an event would be seared into the collective psyche, a story so powerful it would be told and retold for hundreds of generations. Over time, the specific details of one valley or one coastline being lost would transform into a universal archetype, the story of a global flood that wiped out a previous age of humankind. These myths are far more than simple fables. They are the deep, ancestral memory of our species, a haunting record of a time when the oceans rebelled and the continents themselves seemed to sink. They remind us that our ancestors lived through geological upheavals that reshaped the map of their world, a map we have long believed was fixed, but which we now know is always, imperceptibly, on the move. The ocean's ability to reclaim the land is the most visceral force of continental drowning. While tectonic forces warp the stage, sea level change is the flood that fills it. Throughout Earth's deep history, the global ocean has not been a constant. Its surface has climbed to staggering heights, at times more than 200 meters above our current shorelines, and plunged to profound depths, leaving vast shelves of dry land exposed for millennia. This great pendulum swing is governed primarily by the epic cycle of ice ages. During a glacial period, colossal ice sheets, miles thick, form over continents like North America and Eurasia. This locks away an immense volume of water, effectively stealing it from the world ocean and causing sea levels to fall. This is how the land of Sunderland was born, a Texas-sized territory exposed by the planet's thirst for ice. But when the climate shifts and the great melt begins, that stored water is returned, and the seas rise in a slow, inexorable advance. This is not the only force at work, however. The very container of the ocean is constantly changing shape. Running along the seafloor for tens of thousands of miles are the mid-ocean ridges, undersea mountain chains where new crust is born. When these ridges are volcanically active and swollen with heat, they displace enormous amounts of water, pushing sea levels higher across the globe. When their activity wanes and they cool and contract, the ocean basins can hold more water and the sea level falls. Even the water itself expands as it warms, a process called thermal expansion that is a significant contributor to the sea level rise we are measuring today. What makes this ancient cycle so urgently modern is the acceleration we are now witnessing. The natural, gradual rise that once unfolded over thousands of years is now compressed into centuries, even decades, due to human-driven climate change. This is not a future threat, it is a present reality, a direct and sobering echo of the ancient inundations that shaped our myths. And as the waters climb once more, they are performing a strange kind of archaeology. Along coastlines from the North Sea to the Gulf of Mexico, the rising surf is eroding shorelines and revealing stunning evidence of past human habitation. The traces of ancient hunting camps, the stone tools of those who walked on land now dozens of meters underwater, are being uncovered by the very force that once hid them. This is the great paradox of the rising sea. It both destroys and reveals, offering us clues from the last time the continent sank, even as it begins the process anew. These submerged landscapes are vast, untapped archives, holding secrets far older than the pyramids. On the seabed, archaeologists are now finding the tangible evidence of the lives that were interrupted by the rising seas. Sophisticated stone tools, the massive bones of mammoths hunted and butchered, and the dark, charcoal-stained circles of ancient hearths are being recovered from the continental shelves. Each of these discoveries is a data point that fundamentally rewrites the map of human prehistory. This is the new frontier of exploration, a field known as underwater archaeology. It employs powerful side-scan sonar to paint a picture of the drowned terrain, revealing the ghostly outlines of river valleys and lakes. Remotely operated vehicles then descend to these lightless plains, their robotic arms carefully retrieving artifacts from the silt. Human divers, equipped with advanced mixed gas breathing systems, work meticulously at depths that were once unreachable, brushing sediment away from tools that have not felt the air for thousands of years. One of the most famous of these lost worlds is Doggerland. This was not a narrow land bridge, but a vast, fertile plain that connected the British Isles to mainland Europe. It was a rich ecosystem, home to Mesolithic hunters who tracked deer through its forests and fished in its rivers. Then the seas rose. The evidence of their lives is now scattered across the bottom of the North Sea, a collection of flint spear points and animal bones that tell a story of a sudden, dramatic end. But Doggerland is not alone. Off the coast of Florida, the remains of ancient campsites lie submerged where early Americans once lived. In the Persian Gulf, the foundations of entire settlements rest on the seabed, flooded when the ocean broke through the Strait of Hormuz. The Baltic Sea hides preserved wooden tools in its cold, low-oxygen waters. These underwater sites possess a unique, almost magical quality of preservation. While ancient ruins on land are weathered by wind and rain, or plowed under by modern agriculture, these submerged landscapes were quickly covered by protective layers of silt and mud. They have been held in a state of suspended animation, safe from the ravages of time. This makes them pristine time capsules, offering a clearer window into the past than we often find on dry land. Every spear tip pulled from the mud is more than an artifact. It is a waypoint on an ancient journey. These finds are helping us trace the precise routes our ancestors took as they ventured across the globe, populating continents by following coastlines that are now deep underwater. These are not merely relics to be catalogued in a museum. They are the evidence from an active crime scene on a planetary scale. The crime was the drowning of continents, and the clues left behind are helping us reconstruct a lost way of life, one that was forever changed when the world warmed and the oceans claimed their dominion. The rolling hills and forested valleys of Doggerland once formed the very center of ancient Europe. This was not a mere bridge, but a vast and thriving territory, a heartland larger than many modern countries, where rivers teemed with fish and great herds of animals roamed through woodlands and marshes. For the Mesolithic people who lived there, it was the entire world, a land of abundance that sustained generations of hunter-gatherers. Their story, however, was being slowly rewritten by a force they could not see. As the great ice sheets retreated, the oceans began their long, steady climb. Coastlines crept inward, season by season, year by year, swallowing the fringes of this world in a relentless, quiet advance. The people of Doggerland would have witnessed their homeland slowly shrinking, the familiar landscapes of their ancestors gradually yielding to the sea. Then came the day that shattered their world. Far to the north, off the coast of Norway, an entire section of the continental shelf collapsed. This was the Storegga Slide, a catastrophic underwater landslide that sent thousands of cubic kilometers of rock and sediment plunging into the deep. The displacement of such a colossal volume of water unleashed a tsunami of almost unimaginable power. A wall of water would have raced across the North Sea, striking the low-lying plains of Doggerland with devastating force. For the communities living there, it would have been a true apocalypse. The surge would have scoured the landscape, drowning the interior and turning the once fertile Heartland into a saltwater marsh. This single cataclysmic event, occurring around 6,150 years before the Common Era, likely delivered the final, killing blow to a land already on its knees from the rising seas. The proof of this lost world now surfaces in the most mundane of ways. For centuries, fishermen trawling the North Sea have hauled up their nets to find not just fish, but the ancient bones of mammoths and lions, alongside finely crafted stone tools that once rested in human hands. These artifacts are the ghostly echoes of a drowned civilization, a poignant reminder that the ground we build upon is never truly permanent, and that the forces which shaped our deepest myths are still very much at work today. These ghostly landscapes are no longer just theoretical. We can now see them with a clarity that would have been pure science fiction a generation ago. The key to this vision is multi-beam sonar, a revolutionary technology that acts like a powerful flashlight in the abyss. Research vessels now traverse the oceans, sending out fan-shaped swaths of sound waves that ping off the seafloor. By meticulously measuring the time it takes for each echo to return, sophisticated computers can construct breathtakingly detailed, three-dimensional maps of the drowned world below. This is not a blurry impression, it is a high-definition portrait of a lost planet. These maps reveal features that tell a clear and compelling story. We can now trace the sinuous, meandering paths of drowned river valleys, carving their way across the continental shelf just as they did when they were filled with fresh water. We can identify the sharp, cliff-like edges of ancient shorelines, marking where waves once crashed against a coast that has been silent for millennia. We can even see the distinct circular depressions of vanished lake basins, holding the secrets of ecosystems long since erased. For instance, in the English Channel, sonar has clearly charted the course of a colossal prehistoric river system scientists call the Fluve Manche. This was not a small stream, but a massive waterway that drained the combined flow of the Thames, the Rhine, and the Seine, carving a deep channel across the land that once connected Britain to France. Thousands of miles away, similar maps of the seafloor off Florida reveal a stunning and familiar sight, an intricate karst landscape of sinkholes and limestone solution valleys. This is the same kind of porous, water-carved terrain you see in the modern Florida Everglades, but this version is now submerged, a clear sign that the entire Florida shelf was once a dry, living world. This technology is the ultimate game changer. It provides the canvas, the foundational map upon which all other evidence can be placed. It tells us where to look. But a map, no matter how detailed, cannot tell us when these rivers flowed or when these lakes dried up. To put a clock on this sunken world, we need to turn to a different kind of deep time detective. These long, unbroken cylinders of mud and silt are the deep-time diaries of our planet. While sonar maps reveal the shape of a lost world, it is the sediment core that whispers its secrets. Scientists drive long, hollow tubes deep into the seabed, pulling up layered columns that can stretch for dozens of meters. Each distinct band in this muddy archive represents a different chapter in the land's history, a timeline of environmental change written in particles too small for the naked eye. To read this diary, researchers employ a kind of microscopic detective work. They wash the sediment through fine sieves, searching for the tiny, indestructible shells of foraminifera. These microscopic creatures are precise environmental proxies, each species living only within a specific range of water temperature and salinity. Finding a layer dominated by deep ocean foraminifera right on top of a layer filled with freshwater marsh pollen is like finding a sentence in the diary that reads, "And then the sea rushed in." The pollen grains themselves are another ancient language. A sudden shift from tree pollen to grass pollen can signal a changing climate, while the appearance of crop pollen could mark the arrival of human agriculture on a now drowned coastal plain. To put exact dates to these stories, scientists turn to radiocarbon dating. Any piece of preserved organic material trapped within the layers, a fragment of ancient wood, a peat moss stem, the shell of a freshwater snail, contains a radioactive clock. By measuring the decay of carbon-14 in these materials, researchers can pinpoint the precise moment to within a few decades when a freshwater swamp was buried by the sea. One of the most powerful examples comes directly from the heart of Doggerland. A sediment core extracted from the North Sea floor might begin with a thick, dark layer of peat, the compacted remains of a thriving freshwater wetland. This peat is filled with the pollen of reeds and oaks and the shells of land snails. Then, abruptly, the peat layer ends. Directly on top of it lies a deposit of gray marine clay, filled with the microscopic shells of saltwater organisms. The radiocarbon date from the very top of that peat layer tells us the final years the land survived. It marks the last season the reeds grew, the last time the land snails crawled before the ocean closed over it for good. This is not a vague approximation, it is a specific date stamped on a continental disappearance. By correlating these detailed environmental timelines with archaeological finds from nearby submerged sites, we can begin to weave a seamless narrative. We can understand not just that the sea rose, but how quickly it transformed the landscape, and how the people living there would have experienced that transformation. The slow creep of saltwater into their freshwater marshes would have killed the plants and driven away the game they relied on, forcing a gradual retreat. Or in the case of a Storega-slide tsunami, the core might show a violent, chaotic layer of sand and shell ripped from the coast and thrown far inland, a stark geological record of a single terrible day. This ability to read the muddy pages of the ocean floor transforms our understanding from a broad sketch into a finely detailed portrait, giving us a profound and intimate connection to the lives disrupted when continents sink. There is a hidden compass locked inside the stone, a silent witness to journeys that spanned millions of years. This is the science of paleomagnetism, the art of reading the Earth's ancient magnetic field as it was recorded by iron-rich minerals in volcanic rock the moment they cooled from lava. When these rocks form, their tiny magnetic minerals align like microscopic compass needles, permanently freezing in place the direction of the planet's magnetic north at that exact time and location. It is a perfect snapshot of the planet's magnetic personality, a memory sealed in stone. For geologists investigating lost continents, this is one of the most powerful tools in their arsenal. Imagine a team drilling a core sample from a deep seamount on the sunken continent of Zealandia. They bring this cylinder of ancient rock to the surface, and carefully analyze its magnetic signature in the lab. The compass direction they find is startling. It points to a magnetic north that is nowhere near its current position, indicating that this rock formed at a completely different latitude, a different part of the globe entirely. This single measurement tells a story of an epic voyage. It reveals that this fragment of continent has traveled thousands of miles, drifting across the planet's surface before ultimately meeting its fate beneath the waves. But the story does not end with a single compass reading. The planet's magnetic field has a restless history, flipping its polarity completely every few 100,000 years. What we call north becomes south, and south becomes north. These flips are not chaotic, they are systematically recorded on the global seafloor. As new oceanic crust erupts at the mid-ocean ridges, it spreads outward, cooling and locking in the magnetic field direction of the era. The result is a symmetrical striped pattern on either side of the ridge, a giant, natural barcode of normal and reversed polarity that charts millions of years of magnetic history. To pinpoint the exact moment a continent like Zealandia began to sink, scientists can match the magnetic barcode recorded in its own rocks to this master barcode on the ocean floor. It is a form of celestial navigation, using the memory of the Earth's own magnetic soul to chart the voyage of a lost world, revealing precisely when it cracked away from its parent, set itself adrift, and began its long, slow descent into the abyss. The legend of Mu emerged not from ancient texts, but from the fevered imagination of the 19th century. Augustus Le Plongeon, working among the Mayan ruins, became convinced he had deciphered a story far grander than Atlantis. He postulated an entire Pacific continent, a primordial motherland called Mu, whose advanced civilization was the true source of all ancient knowledge. According to his theory, when Mu catastrophically sank, its survivors seeded the cultures of Egypt and the Americas. This sensational idea was later seized and wildly embellished by an author named James Churchward, whose popular books painted a picture of a utopian paradise lost beneath the waves. For a public enthralled by exploration and mystery, the story of Mu was irresistible. It offered a single, elegant origin for humanity's greatest achievements, a romantic answer to the complex, scattered story of archaeology. Yet for all its narrative appeal, Mu stands on a foundation of pure fantasy. The entire premise collapses under the weight of basic geology. The central Pacific Ocean floor is not a sunken continent. It is built from a completely different kind of rock, a dense, heavy basalt that forms the planet's oceanic crust. This material is fundamentally incapable of supporting a vast, buoyant landmass like a continent. If a continent-sized mass of granite had ever sunk there, its ghost would still be visible in gravity maps, a massive anomaly pulling downward. No such ghost exists. The story of Mu is a powerful lesson in the allure of pseudoscience. It shows how a compelling narrative can override factual evidence, feeding a deep-seated human desire for a lost golden age. It serves as a vital checkpoint in our exploration, forcing a clear distinction between the romantic stories we wish were true and the monumental, evidence-based realities of a dynamic planet. The true forces that sink continents are not mysterious cataclysms from a forgotten age, but the slow, inexorable, and far more wondrous processes we can observe and measure today. The relentless pull of gravity does not end at the ocean's abyss. It continues its work deep below at the planet's ultimate recycling centers, the subduction zones. These are the grinding collision points where one tectonic plate is forced beneath another. Picture the dense, heavy basalt of an oceanic plate meeting the buoyant granite of a continent. The ocean floor, being heavier, has no choice but to dive downward, sliding into the mantle's inferno. The continent, however, is far too light to follow. It acts like a giant, immovable raft, refusing to be dragged under. This does not mean it escapes unscathed. The collision is a geological war zone. The continental edge is crumpled, fractured, and thrust upward into massive mountain ranges like the mighty Andes of South America. This is the violent birth of a new coastline, forged in the pressure of a continental collision. But even as the continent resists, it loses pieces of itself. Layers of sediment and small fragments of crust are scraped off the descending plate and plastered onto the continent's edge, a process geologists call accretion. Yet some of that material is not added on. It is carried down into the abyss. This is sediment subduction, the final journey for the eroded remains of ancient landscapes. Every grain of sand, every piece of rock that has ever washed into the sea from a continent's rivers is potentially destined for this fate. It is dragged hundreds of kilometers down, where immense heat and pressure eventually melt it back into the mantle from which it came. This is the final stage in the epic rock cycle, the ultimate recycling program that has been running for billions of years. The material of a lost continent like Zealandia does not simply rest on the seafloor for eternity. Over deep time, the moving plates may guide it toward one of these subduction zones where it will be consumed, melted, and returned to the Earth's fiery interior. This process of destruction is perfectly balanced by one of creation. The same subducting plate, as it plunges deeper, releases water that was locked in its rocks. This water lowers the melting point of the hot mantle rock above it, triggering the formation of new magma. This buoyant molten rock then begins a slow ascent, pushing its way back toward the surface. It erupts through the overlying continent to form a line of violent and beautiful volcanoes, known as a continental arc. The entire Cascade Range in the Pacific Northwest, from Mount St. Helens to Mount Rainier, is a product of this very process. In a very real sense, the lava flowing from these volcanoes is the reincarnated substance of ancient seafloor and the sediments it carried, including the remains of worlds that sank long ago. The continents are not static monuments. They are dynamic, living entities, constantly being eroded at their edges and renewed from within. Their very substance part of a planetary heartbeat of death and rebirth that spans the eons. The slow-motion drowning of a continent is a geological epic, but the ocean can also erase land in a single, terrifying instant. Volcanic islands, those majestic peaks rising from the sea, are often built on foundations of immense instability. Consider the Hawaiian chain, a string of giants born from a hotspot of magma. As a volcano like Mauna Loa grows, its colossal weight, often trillions of tons of rock, presses down on the flexible oceanic crust beneath it, causing the entire foundation to sag. At the same time, the volcano's own flanks become oversteepened, their rock fractured and made heavy with groundwater. This creates a precarious balance, a landslide waiting for a trigger. That trigger could be a powerful earthquake or a new pulse of magma shifting deep inside. When it gives way, the result is a catastrophic flank collapse. A colossal slice of the island, a mountain within a mountain, can detach and slide into the deep ocean in a matter of minutes. We are not talking about a rock slide, but the movement of hundreds of cubic kilometers of solid rock, an entire piece of geography suddenly set in motion. The effect on the ocean is immediate and apocalyptic. Such a vast displacement of water generates what is known as a mega tsunami. This is not a normal wave, but a deep, energetic pulse that travels at the speed of a jet aircraft across entire ocean basins. When it reaches a distant coastline, that energy rears up into a wall of water that can be hundreds of meters high, scouring the land clean for miles inland. The geological record is littered with evidence of these past cataclysms. Around the Hawaiian Islands, sonar maps reveal enormous debris fields on the seafloor, the scattered rubble of ancient collapses. One of the most studied potential collapse zones is on the island of La Palma in the Canaries, where a western flank shows deep cracks and a history of movement. While a flank collapse does not sink a continent itself, it demonstrates a terrifying principle. It shows that the solid ground we take for granted can be dismantled not over millennia, but in the time it takes to drink a cup of coffee. It is a visceral, shocking reminder that the planet's most dramatic reshaping often happens in a single, violent breath, a counterpoint to the eons-long sinking of continents, and a sobering warning of the destructive power still slumbering beneath the waves. The same tectonic forces that drowned ancient worlds are actively reshaping our future. The Atlantic Ocean is widening by a few centimeters each year, a slow but relentless pull that pushes the Americas further from Europe and Africa. Meanwhile, the mighty Pacific is being consumed, its oceanic crust diving beneath the surrounding continents in a slow-motion demolition that shrinks the basin century by century. These are not subtle shifts. Africa is plowing northward into Europe, a collision that is already crumpling the landscape and will one day seal the Mediterranean Sea forever, raising a colossal mountain range to rival the Himalayas. At the same time, Australia is on an unmistakable trajectory, sailing north to merge with the islands of Southeast Asia. We can plot the course of these continental wanderers, projecting their paths millions of years ahead. The result is an inevitable reunion. In perhaps 50 to 200 million years, the scattered fragments of Earth's crust will reassemble into a new supercontinent, a landmass scientists call a major or Pangaea Proxima. This future world will be almost unrecognizable. The slow, grinding collisions will thrust up new mountain ranges that scrape the sky, fundamentally altering wind patterns and rainfall across the entire globe. As the continents squeeze together, some of their margins will be compressed and buckled upward, while others will be stretched thin and pulled downward, destined to sink beneath the rising seas that will flood the new ocean basins created by this continental dance. This is the grand geological destiny of our planet, a cycle of assembly and breakup that has repeated itself for billions of years. Yet a much faster version of this drowning is already unfolding. The sea level rise driven by human-induced climate change is a small-scale, rapid echo of these vast forces. Our coastal cities are facing a modern inundation, not from the bending of the crust, but from the expansion of warming seawater and the meltwater of glaciers. This present-day crisis offers us a poignant, urgent glimpse into the planetary processes that have, throughout deep time, erased entire continents from the map. The ground we build our civilizations upon is not a permanent stage, but merely a single frame in an endless film of change. Our entire civilization rests upon a foundation we assume is eternal. We build cities of steel and glass, we draw borders on maps, and we plant flags in the soil, all with the unshakable belief that the ground itself will not betray us. This is the grand illusion of permanence, a psychological comfort that the knowledge of sunken continents systematically dismantles. Learning that a landmass the size of Zealandia can vanish forces a perspective shift of almost dizzying scale, a plunge into what is known as deep time thinking. It is the recognition that human history, with all its empires and achievements, occupies little more than a single breath in the billion-year life of the planet. This realization can be deeply humbling, even unsettling, as it removes us from the center of the story and places us within a far grander, more indifferent narrative. Yet this same perspective carries a powerful message of resilience. The Earth story is not one of permanent loss, but of constant transformation. For every continent that sinks beneath the waves, a new volcanic island breaches the surface. The destruction of one ecosystem, like the lush forests of Sunderland, clears the stage for the evolution of entirely new life in the oceans that replace it. This cyclical rhythm of death and rebirth is a cornerstone of many ancient philosophies, from the Hindu concept of kalpa to the Stoic acceptance of natural change. Modern geology now provides the evidence for this ancient wisdom, revealing a planet in a state of perpetual creative flux. This is not a story of meaningless chaos, but of a system that constantly reinvents itself. The lesson is not one of despair, but of profound acceptance. Our own cities and cultures, for all their concrete and tradition, are just as temporary as the lost continents we study. This understanding of impermanence is not a call for inaction, but for a wiser form of action, one that plans for change rather than denying its inevitability. The fate of these lost worlds offers us more than just a history lesson. It provides a crucial framework for navigating our own future on a planet that is never truly still. The geological past is no longer a distant curiosity. It is a mirror reflecting a future we are now actively creating. Those slow, post-glacial rises that consumed Doggerland and Sunderland over millennia are being compressed into mere centuries by human activity. The rates of sea level rise measured by our satellites today are, in some cases, matching or even surpassing the most rapid pulses from the ancient past. This is not a gradual change our descendants will face. It is a transformation unfolding within our own lifetimes. Our sprawling coastal megacities, from Miami to Mumbai, are the modern analogues of those Mesolithic hunting camps on the continental shelf. They are built on the same vulnerable front lines, facing the same inexorable force. The geological record speaks with chilling clarity on one point. When the oceans begin their advance, they do not pause for consensus or debate. They continue their climb until a new balance is struck, reshaping coastlines and redefining what is land and what is sea. This long view of history offers us something invaluable, a catalogue of human responses to inundation. We can see where ancient communities successfully adapted by moving to higher ground, a process we now call managed retreat. We can also find evidence of societies that attempted to hold back the sea with primitive walls and earthworks, only to be ultimately overwhelmed. Their failures teach us that while coastal defenses are crucial, they have limits against a determined ocean. The stubborn refusal to acknowledge the water's power has been, time and again, a prelude to catastrophe. This deep time context transforms the artifacts we pull from the seafloor from mere relics into urgent memos from past civilizations. They are silent witnesses to the fact that the ground can indeed vanish, and that our greatest asset in facing this reality is not stubborn permanence, but intelligent, foresighted adaptation. A continent does not plunge into the ocean depths like a torpedoed vessel. This cinematic image is perhaps the most persistent myth about lost lands. The reality is far slower and, in its own way, more profound. The disappearance of a continent is a saga of gradual subsidence, a sinking measured in millimeters per year, compounded by the creeping ascent of the sea over countless generations. It is a tragedy written not in a single cataclysmic act, but in the slow, inexorable turning of geological pages. Equally misleading is the search for a single global flood that inspired every legend. The geological record reveals a tapestry of regional inundations. The drowning of Sunderland was a story of the tropics, while the collapse of Lake Agassiz unleashed its floodwaters in the north. Different coasts, different times, same terrifying result for the people who lived there. This explains why flood myths are a universal human theme, yet their details vary from culture to culture. They are not memories of one event, but parallel memories of many. Then there is the allure of the advanced lost civilization, a kingdom of unimaginable technology and wisdom swallowed by the sea. While a compelling narrative, archaeology offers no support for this idea. The inhabitants of places like Doggerland were not builders of crystal cities. They were resilient Stone Age hunter-gatherers, their lives defined by the rhythms of the land and the hunt. Their tools were made of flint and bone, not mysterious alloys. Their lost world was one of forests, rivers, and marshes, not gleaming spires. By clearing away these layers of misconception, we can finally see the true story in its full, majestic scale. It is a story not of a single catastrophe, but of the planet's deep, rhythmic cycles. It is a story of human adaptation and resilience in the face of a changing world. This clearer vision allows us to pull all the threads of evidence into a single, coherent picture, a grand synthesis that connects the deepest past to our looming future. This unified view of our planet reveals a spectrum of disappearance, from the slow-motion drowning of an entire continent to the swift erasure of a single human homeland. We see the same forces at work, only operating on different clocks. The tectonic stretching that doomed Zealandia over 80 million years is the same force that, on a smaller scale, causes coastal lands to gradually subside today. The sea level rise that flooded Doggerland's plains is the same phenomenon now lapping at the foundations of our own coastal cities. Human experience is woven directly into this geological fabric. Our oldest stories of great floods are not fanciful inventions, but likely the long, echoing memory of shorelines retreating and lands vanishing beneath the waves, a trauma passed down through hundreds of generations. Replacing the mystery of lost continents with the mechanics of plate tectonics and climate cycles does not diminish the wonder, it amplifies it. The realization that our world is a dynamic, ever-changing stage is far more breathtaking than any single myth. This grand synthesis of geology and human history brings us to a final, compelling frontier. If the Earth's crust is this dynamic, and if past lands now lie hidden beneath the sea, what other lost worlds might be down there, still waiting to be discovered? The next chapter of exploration is not about finding legendary cities of gold, but about using our new geological understanding to predict where other forgotten fragments of continent might be hiding in the deep. Could the silt of the continental shelves hide chapters of intelligence written by other hands? This provocative question pushes beyond myth into a daring scientific frontier, the search for pre-human civilizations. Mainstream science offers a firm and clear answer, at least for any society that mirrored our own industrial age. The global geological record contains no layer of plastics, no spike in artificial radionuclides from atomic energy, no chemical traces of widespread pollution that would mark an advanced technological society. Our planet's strata tell a continuous story of natural processes, abruptly interrupted only by the very recent arrival of humanity's own signature. The absence of this global techno-fingerprint is compelling evidence that we are the first civilization to reach this particular stage of development on Earth. Yet this leaves a vast and tantalizing gap. What about a society that never forged steel, but that built complex structures, established permanent settlements, or developed a sophisticated culture entirely distinct from our own? We know that other hominids shared this world for millions of years. Species like Homo erectus with their long reign and crafted tools, or the Neanderthals with their evidence of symbolic thought and burial rituals, possessed a profound intelligence. Their world for hundreds of thousands of years was the world of the last ice age, a planet where the vast continental shelves we now call Doggerland and Sunderland were thriving, accessible landscapes. These were the fertile coastal plains, the river valleys, the very heartlands where such species would have lived, hunted, and perhaps built a way of life we can scarcely conceive. The immense challenge and the breathtaking possibility is that the vast majority of these Ice Age coastal zones now lie underwater, utterly unexplored by archaeologists. Finding a single submerged Neanderthal structure, a patterned arrangement of stones that speaks of communal gathering, or a cache of artifacts demonstrating a leap in symbolic art would shatter our understanding of deep history. It would rewrite the narrative of intelligence on this planet. This search is not about finding sunken cities of legend, but about uncovering the subtle, fragile traces of a different kind of mind. It pushes the limits of underwater archaeology, demanding new technologies to sift through millennia of sediment on a continental scale. The very difficulty of this quest reminds us that our current understanding of the past is built on the tiny fraction of evidence that remains on dry land. The greatest discoveries about who we are and who else might have shared this profound capacity for culture may still be waiting in the silent darkness of the drowned world. Our journey has taken us from the fiery birth of the first Kratons to the high-definition sonar maps of Doggerland, from the philosophical ghost of Atlantis to the undeniable geological reality of Zealandia. The evidence is no longer a collection of scattered clues, but a unified and powerful testament to a fundamental truth. Continents do sink, and entire worlds are continually submerged and reborn through the grand, inexorable cycles of tectonics and climate. This is not a story of random catastrophe, but one of planetary rhythm, the slow, powerful heartbeat of the Earth itself. It is a narrative that teaches us a profound sense of humility, revealing that the very ground upon which we build our greatest cities and draw our most permanent borders is not the immutable foundation we assume it to be. Yet, this same story speaks to an incredible capacity for resilience. Life and humanity itself has always found a way to adapt and persevere through these monumental changes, retreating from advancing coasts and learning to thrive in new landscapes. As we now face our own era of rapid environmental transformation, the lessons whispered from these lost worlds are more urgent and relevant than ever. The past is not merely a record of what has been, it is a vital guide for what is to come. It reminds us that our greatest strength lies not in resisting change, but in understanding its nature and adapting with foresight and wisdom. If this journey into Earth's hidden history has captivated you, subscribe for more deep dives into the mysteries of our planet and share your own thoughts on these lost worlds in the comments below.